Good afternoon, Professor Schilling and the fellow classmates. Today we are going to talk about the biometrics, and we are group 4. I'm Norman, Cynthia, and Marcus. So for biometrics, we first look at the definition of it. And you can see that biometrics is actually the science and technology of measuring and analyzing the biological data. And also it is the technologies used nowadays for unique measurement and analyze one or more intrinsic human body characteristics. So I will give you an example of the simple biometric use, which is quite typical. On your laptop, you can see a scanner for fingerprints. It is very generally used in nowadays, and it is actually using the technology of biometrics. So for biometrics characteristic, there are two subgroups. The first one is physiological, and it means that those characteristics are related to the shape of the body, like the fingerprint, the face recognition, and the DNA. And the second type is the behavioral, and that means those characteristics are related to a person's behavior, such as the typing rhythm, the writing rhythm, and the voice. So some scientists may regard this type as another subgroup as the behavioral metrics. So now we will look at deeply the biometrics devices and the system. And they are simply divided into two types, the verification and the identification. So for verification, it is one-to-one, and it means that when a person he claim that he is one person, and you will have this biometric system to test whether his claim is true or not. And for identification, you'll have a list of biometric characteristics of different people in your database, and you will simply play the join a dot game for matching this unknown person to match some of the characteristics in your database. So I'll now talk about the fundamental structure of a biometric device. As you can see on the slide, here is the diagram, which is maybe a little bit complicated. So before you enter the internal structure of the biometric system, you'll have the scanner, as I've mentioned it in your laptop, the fingerprint scanner, and it will scan and have the inputs of your biometric characteristics, which is your fingerprint. So in the scanner or in the sensor, it will do some encryption to protect your personal data. And after that, the inputs of those characteristic data will be passed into the internal structure of the biometric system. And first of all, it will have the feature extractor. It will extract the useful data by this extractor, and useful data will then pass to the template generator, which will generate a template which is uniquely for your own characteristic with match points. Those match points are later used for comparison. So those comparisons are done between the matcher with the stored template. The stored template also have quite a number of match points, which can enable some comparison between your templates and the stored templates. So after the comparison and some calculation in terms of numerical value, and the system will tell you that it is approved or denied for your access. So I'll now pass the time to my group mates to talk about the application of some biometric device.
So this time we will focus in two main applications. The first one will be fingerprint recognition, and it is a very common use of recognition method, which is introduced more than 100 years ago, and this is so common that many devices have now changed to fingerprint recognition, and this is widely used in the community. And these are the general fingerprint characteristics and some technical terms for defining simple fingerprints. So for the fingerprint recognition, the whole algorithm can be mainly divided into two parts. The first part would be image processing. After you collect the data through the sensor, you need to enhance the image by eliminating the noise or cut the areas that you think is heavily corrupted, so that to ensure the quality of the input is good. Afterwards, we will binarize the data and turn it into a binary image. And afterwards, you fin the binarized image, and we try to use that finned image to reconstruct, using the range to reconstruct another image. And afterwards, we will extract the minutiae from the reconstructed image for comparison. So this process is for image processing to turn an input into an output, that is the extracted image for comparison. And the next step will be matching. Matching, you can see the picture below that it is the first step would be the minutiae analysis, that is to calculate the angles or the distance between two minutiae. That is, for example, like the bottom right, it is calculating the angle, whether it is similar or not. And you, after doing these analysis, you will calculate the similarity, both for local and for global, and to compare which have the highest goal. For example, you have the similar angles and the similar distance, and you match different samples so that you can choose the best matching fingerprints that match what you are going to find. And these are the general process of the matching. And this is one application that is using this sensor, you can measure the capacity between the sensor surface and skin, so that you can turn the input into a real image that is processed through the previous mentioned process to really match the fingerprint. And it is generally what fingerprint recognition do. So afterwards, the second application we will talk about is the iris application.
Thank you, Marcus. So now we come to the second important technology, that is the iris recognition. So iris is just a colorful tissue in your eye, just controlling the amount of light you can see. Why we choose iris as the tool is because it has a random pattern, and that it is unique even among genetically identical twins. So there are basically 6 steps to in this iris recognition process. And the first one, localization, capturing, extraction, analysis, encoding, and matching. And we'll go through the important ones step by step. The first one is localize and capture. This is namely to how do you capture a good quality image for analysis. And we have mainly 2 ways. The first method is near-infrared imaging, which is called NIR. It is the most popular used nowadays because it can capture the best quality. Because it is in black and white, so there's no light reflection, and you can keep the quality of the photo. However, because it's in plain color, so we do not contain the information about the color of your iris. So there's another method. It's called the visible wavelength. However, although this method could conclude the color of your iris, however, because there is color, there will also include light reflection in your eyes, so it will affect the accuracy of the image. And then we'll come to the part about encoding. This is how do you convert the image you have captured into the codes for storage. And in the image that you have just captured, you have to select the range with the best quality, that is with the least noise. And then we'll use the 2D Gabor wavelets to transform it into a phase graph. And to make it not too affected by the reflection or illumination, we will not include any amplitude information there. And then we'll translate the phase into some bits and the iris codes. Note that this is an irreversible process, which means that you cannot simply use the codes and try to figure out what the iris will look like, so it will protect the privacy. And then we have, last but not least, the matching process. How do you decide whether the 2 iris belong to the same person? So we're making use of the Hamming distance, which we have learned in class. First of all, we'll compare the 2 iris codes. we will use 0 to indicate it's the same code and same bit, and then we use a 1 to indicate it's a different bit. And then if less than 1/3 of the bytes are the same, we'll conclude that it is the same iris and that it is statistically dependent. So actually this technology has already applied in many nowadays product. For example, we'll use it to control the access to premises and to recognize whether the mobile phone belongs to the owner to allow the access. So now I'll pass the time to Norman to discuss about the difference between the two technologies.
Thanks, Cynthia. Now you have heard those features about iris scanning and also the fingerprint recognition. So we'll do a comparison between them on 4 aspects, which are the accuracy, uniqueness, the safety, and the price. So for accuracy, iris is definitely more accurate than fingerprint because iris is the only organ that is well protected. But on the contrary, fingerprints may wear off due to some labor or due to some thing you do as usual. For the next part is uniqueness. Iris is 100% unique, but for fingerprint it may not, because you will find some quite similar or even identical fingerprints from 2 identically same twins. And for safety, iris scanning is actually not very well developed nowadays, and it is a little bit dangerous for our eyes because some light wave may be dangerous to our eyes, may damage the internal structure of our eyes. But for fingerprint, it is definitely very safe and cause no damage to us. And the last part is the price. As you can see, lots of fingerprint scanner are adopted everywhere, such as on your laptops. So you will know that the price of fingerprint recognition is quite cheap compared to iris scanning. But for iris scanning, as it has not been developed for a long time, it is quite a new technology. So you will have a lot of cost to invest on this iris scanning. So this is the end of our presentation. Thank you.